Welcome to the lecture Knowledge Engineering with Semantic Web Technologies. This is the first lecture, Knowledge Engineering and the Web of Data. And in this first part of the first lecture, we will talk about the limits of the traditional web. So to talk about the limits of the web, we have to go back a little bit in history. And first we talk, of course, about the internet, which is the predecessor of the web. So here these three people you see here are responsible for the design and the vision of the first computer network. You see here a brief sketch of the first 4 computers that were switched together in 1969. And what they envisioned was more than a traditional communication medium. It was a very special medium, as you see here from the excerpt from this vision paper I have given you here on the slide. So let me read this for you. We are entering a technological age in which we will be able to interact with the richness of living information, not merely in the passive way that we have been accustomed to using books and libraries, but as active participants in an ongoing process, bringing something to it through our interaction with it, and not simply receiving something from it by our connection to it. So this kind of communication medium, from the beginning, right from the start, was meant to participate for all of its listeners. And this, of course, is a huge difference. So back in those days, in the 1960s, and this first generation of the internet lasted until the late 1980s, was the so-called era of computer-centered processing. So what does it mean? So we look now briefly on how the user got the information from the internet. So some of you might remember this. First, you had to open a terminal window. Then you had to connect to a remote system. Of course, you had to know the address of the remote system and all the credentials that you need to log into the remote system. And then there, you had to look at the file system. So you retrieved the file system data from the remote system. And then when you have found what you were looking for, you download the specific file from the remote file system to your local file system. And then you could read the file on your local system. So this was really complicated, and the problem was doing this in this terminal window required, of course, special commands, and you have to learn a special language, a special syntax to do this. So this information access required expert knowledge, and this was really expensive. So in the terms what you had to learn and what you had to invest to get to the information. And to do information retrieval was almost impossible since it was really more expensive. So this was the very first generation of the internet, and only experts were connected to the internet. But this all changed with the beginning of the 1990s with the arrival of the web, the World Wide Web. Because here we are looking at so-called document-centered processing. So the document became the focus, simply because you had a software which was called the browser, which provided a graphical user interface for the user, which means you only had to type in your browser the address of the document you were looking for, and then inside this document there were links connecting documents with each other, and simply by clicking on a hyperlink you could download the next document which was connected with your document. So this means both documents were somehow related, and this opened a completely new way to navigate the web. So information access now does not require expert knowledge anymore. So this was great, hey. And even information retrieval became usable simply because there were so-called web crawlers and web search engines which provided an index, and inside this index of the web you could search for your information. So this was, or this is still the state of the art, and of course this is much more convenient than before, and this also is responsible for the huge success of the web, which you can see here, for example, in the growth scale or in the growth diagram of the web. You see here the connected hosts which have an own static IP address in the web, and these are more than 1 billion computers connected to the web with an own IP address, and it seems as if there is no limit of growth. Of course, you see that this curve already reaches some point of saturation, but this is also the Internet Protocol standard, the old one, IPv4, is also responsible for that saturation effect. But this is not subject of our lecture. So there is a huge growth. And the problem is, so let's state this with the word of famous author Douglas Adams, the web is big. It's really big, and you just won't believe how vastly, hugely, mind-bogglingly big it is. So the point is, there are not only the documents provided by some users or companies, there is even more. The web is getting bigger by the minute simply because we now connect all kind of devices, so for example, entertainment devices or household devices to the internet. And this is now becoming the Internet of Things because all these devices are gathering data. They have sensors, they are gathering data, the data is put on the web, and it's not simply put on the web. You also have these social media platforms, and also these devices can provide data to the social media platforms, and they can then communicate also with each other via social media platforms. So there is a huge growth of data in the web. And one of the problems there is, of course, we have to make sense of it and we have to find what we are looking for. So, one example, you get a website like this, and let's pretend you are from, let's say, a Western cultural community. So you won't be able to understand what's going on inside that website. So the problem is, if the machine, for example, reads the information, so if a computer gets across information like that, no matter in which language it is written, the problem is you cannot determine, or the computer cannot determine what information is important and how should you know that. So, for example, this is a newspaper website, and the question is, what is here news and what is commercial? So how is the information you see here somehow related by content? And what does the information mean? So these are really important questions which have to be solved if we want to deal with this kind of information overflow in the web. So the point is, usually humans have a lot of experience, a lot of so-called contextual knowledge and world knowledge to solve this problem. So we are used to dealing with problems of information gathering and information understanding all of our life. So we also are able to understand written information on the web if it's written in a language that we do understand. But for the machine, this of course is quite a problem. And we need the support of machines to filter and to gather information for us from the web, to find out what is really important. The problem on the web today is it's based on a so-called markup language, HTML, the hypertext markup language. And HTML describes how the information you see is presented in the web and how this information is linked with each other. So it provides the infrastructure of this web of documents. But unfortunately, HTML does not describe what the information really means. So it's primarily intended for the usage of humans and not for the support of machines. You see this, for example, in the so-called information retrieval dilemma. So you see here an image search that I tried out, and you can guess for what kind of keyword I was looking for. So here I was looking for Jaguar. And of course, this is ambiguous, an ambiguous term. So it means natural language, for example, has ambiguity in it. So this is also called polysemy. It means you have a word, and this word can have multiple meanings. So for example, Jaguar can mean, for example, the car, but on the other side also the cat. On the other hand, it's also vice versa, that you can express the same information content with different words, with different expressions. So these are synonyms or metaphors. And of course, traditional information retrieval, which is usually based on the comparison of texts, on the comparison of strings and characters, does not necessarily involve also the resolution of the ambiguity of natural language or different ways how we can express the same kind of information and the same kind of knowledge. So this is also a big dilemma. Moreover, look at a picture like that. So possibly some of you can do something with this information and can understand it. But you need a lot of experience, you need a lot of contextual knowledge, so you have to know what kind of sports this is and what does this mean, Saturday Night Football and the hashtag SNF. And on the other hand, you have to know who is Heisenberg. Heisenberg, is this physicist? Definitely not. So this is really dependent on a specific culture, on a specific context to understand this information. And there is many information hidden inside that picture or in these words you see here. And this is so-called implicit knowledge, implicit information. So it means the information does not necessarily always have to be specified explicitly, but sometimes it must be derived via so-called logical deductions from the available information. And this, of course, is even more complicated for machines. So we see that it's really important to understand the meaning of information. So what is meaning? And what terms and what definitions and what concepts are hidden behind this concept of meaning, we will see in the next part of the lecture.